So we were challenged to build a machine that could sort several different parts, and the requirements stated that we needed to be able to sort 6 different parts and also have several other parts on the conveyor belt, which would go into a 7th reject. As the pieces given to us ended up being of many different shapes, many different sizes, many different materials, we eventually decided after some brainstorming that we would need 2 groups of sensing in order to sort all the pieces. So the first group of sensing, shown here, is embedded in our hopper system, and it consists of 3 proximity sensors. These 3 proximity sensors will sort the pieces based off of whether it is ferrous metal, a non-ferrous metal, or not a metal at all, so these plastic pieces here. After that, based off of the data gathered in this group of 3 sensors, this data is sent to our camera and the C code that controls our camera. Now, our C code that controls our camera, once it receives the image, is stripped and will take just a single image, capture very, very efficient code, just taking a single image and capturing a single picture. When it processes this one image, it looks for the contour around the image, and once it finds that contour, it takes several different statistics. It finds the perimeter of this contour, it will find the area of the image in this contour, and it will also calculate the area to perimeter ratio. Using these 3 parameters, we already have a database in our C code of parameters for every single different part that we were given. And we take these 3 measured parameters and we match them to this database. And based off of the matching, we can identify exactly which piece it is. So previously, we already know which 6 pieces we will be looking out for, and based off of which piece we identify, then we say, okay, yes, it's going to be go into bin 1, 2, 3, 4, 5, or 6. So after the camera code has processed, it will send a signal back to Simulink, and it will tell Simulink which bin it would like for the piece to go into. And Simulink takes this data, Simulink will give a certain delay to this data depending on the position of the bin, and then it will relay this data to TIVA, another microcontroller, and TIVA is used because it has many, many PWM outputs. And TIVA basically serves as a signal relay for these PWMs, and it will send PWM signals to each of our 6 servo motors, shown here. Every one of these servos corresponds to a bin, and utilizing the PWM output from TIVA given at the right time, it will sort the pieces into the respective bins. And if the piece matches our database, but the piece is not supposed to be one of these 6, none of the servos will move. They were all given values of 0, and the piece will roll off into the bin at the end.
Alright, at the beginning of our system we have 3 sensors that detects the different part types. If you drop in a plastic part, you can see that only this sensor trips, so we know that it's plastic. If you drop in a steel part, you can see that our steel sensor and our other sensor, which detects everything, both give a signal, so we know that it's steel. And then if you drop a brass part, our brass sensor and then our other sensor, which detects everything, sends a signal, so we know we have a brass part.
So how the camera works is once we get the data from the sensor, we start our image processing and starting collecting the data, and then from our database we see what part it is, and then send the information to Simulink, which again sends the information to TIVA. So now you're going to see on the screen how the parts is being detected. So this is the first.
The second. This one, I don't know, what you do, you think? I gotta format all of it tomorrow.